Hello, everyone. Chapter 2, we're looking at the algebra of functions. And really, what this is doing mathematical operations on the functions. And notation wise, it's important that you're able to understand this that way whenever you see it. Because if you don't look at this and become familiar with it whenever you just see it in a problem, this right here can be confusing. It's like, oh my goodness, what am I supposed to do? So, just understand that f of x plus g of x, those are representations of a function. Okay, can simply be written as inside the parentheses f plus g of x. And it's the same for all of these: addition, subtraction, multiplication, and division. And one of the key premises of mathematics is trying to be able to think of the simplicity of what you're doing. In all the math that you do, have done, will do, are doing right now in this course, you will always add, subtract, multiply, and divide. You'll always do those four things. What it is, which each thing that we learn, we kind of see, okay, this is how you actually do those four mathematical operations for what we're doing. We give you a little rule, a little postulate, a little theorem that allows you to be able to do those four things. So, with that being said, I want to look at an example. I've given us two equations, two functions. One's a linear, one's a quadratic. One I'm going to call f of x, one I'm going to call g of x. And we're going to perform these operations on these. So this is what I have. So I have f of x plus g of x. And what that simply means is, what is f of x? It is 2x plus 4 plus g of x. And what is g of x? X squared plus 2. Combine like terms and write your term of the highest power first. So I have x squared plus 2x plus 6. G of x, okay, and one other thing I want to make sure. Addition and multiplication, these are commutative operations. Meaning if I say a plus b, that also equals b plus a. Subtraction and division is not the same. AB is the same as BA. So this is for instance, this is 1 plus 3 is 4. And 3 plus 1 is 4. 2 times 3 is the same as 3 times 2. It is not the same for subtraction and division. They are not commutative. So, back to our problem. G of x, that is x squared plus 2 minus f of x, which is 2x plus 4. Subtraction, I'm going to have to make sure that I distribute that negative sign to both of the terms in there. So both of these, since they're both positive, become negative. So what I'm looking at here is x squared, minus 2x minus 2. And this one here, we're going to multiply. F of x is 2x plus 4. And g of x is x squared plus 2. And this is simply the FOIL method, or you're distributing each term. So I distribute the 2x to both of those, and then I distribute the 4 to both of those. And what this becomes, let's see, 2x cubed plus 4x plus 4x squared plus 8. So let me order it the right way. 2x cubed plus 4x squared plus 4x plus 8. And then my division, or my quotient, or my rational function, we're not going to simplify unless we can, unless we could factor a couple of terms out, but otherwise we will just leave it as the function of g of x over the function of f of x. Okay, we've rewritten our functions. And again, what this one actually is, what I have here is simply this. And here, what I have, whoops, getting ready to write f. And here I have, and I can just write as that. I don't have to put the dot in between. And here, what I have is that. Those are my new functions that I'm going to be able to use. So let's see here. Let's make sure we highlight these. And what I've created from those two, I've created a quadratic, a cubic, and a rational, comprised of a quadratic and a linear. And that's it. Now what I'm going to show you is a little bit more behind this. So we know our functions, and I'll slide them over so y'all will be able to see them as we work through. But what I want to do is be able to evaluate at a point for those functions. So let's see here. That can kind of help us. So I know what f of x plus g of x equals after I've done the mathematical property of addition on them. It equals x squared plus 2x plus 6. So what I'm saying is let's let x be 3. So I know that I'm going to have 3 squared plus 2 times 3 plus 6. So that's going to be 9 plus 6 plus 6. What was it? 21. There's my value, 21. And now let's do g of x minus f of x, which is x squared minus 2x minus 2. So x squared minus 2x minus 2. And what we're going to do is we're going to plug in the value of 3 for x. And we're going to solve. So that's 9 minus 6 plus 6. It gives me 9. And then I have my f of x times g of x. Two x cubed plus 4x squared plus 4x plus 8. And again, I'm evaluating for x equals 3, so everywhere there's an x, I'm plugging in a 3. Alright, so 3 cubed. 3 cubed is 27. And 27 times 2, that's 54. I'm going to write these out. I won't be able to remember them all. And 3 squared is 9. And 9 times 4 is 36. And 4 times 3 is 12 plus 8. So let's see. 54 and 36. It gives me 90. And 90 plus 20 is 110. 110. And then my last one is, and we did not go through and simplify, it is simply this. Now, again, substitute in the number 3 for my x's. I end up with 3 squared plus 2 over 2 times 3 plus 4, which is 9 plus 2 is 11 over 10. 11 tenths. Leave your fractions improper. Don't make them whole number, mixed number. You just get more work to do. It's easier mathematically to do your operations with an improper fraction. Of course, we spend most of your general education teaching you that you shouldn't have an improper fraction. Okay, So I've shown you how to evaluate using that. I want to be able to look at something else, okay, with this. Uh, is just showing you like one or two of them. If I were to simply solve for f of x being 3, so f of x is 3. My value for f of x was 2x plus 4, so 2 times 3 plus 4, which equals 10. Don't ask me why I put that in there. And then g of 3, and my function for that was x squared plus 2, so 3 squared plus 2, which equals 11. And then I were to add these two together, I would get 21. Same thing I got up here. So there's two ways to do it. You can evaluate each individual function and find out, okay, if x is 3, what is my y value going to be? Find the y values for both of them, your f of x and your g of x, and then perform that operation just on those numbers, or you can go through and work it just like this. Now, one quick thing that I want to be able to show you, and for instance, this is just again for the addition, what we're looking at. Okay, being able to see. This is Desmos.com. Why did you do that? Okay, this is Desmos. And what we're doing is we're looking at, this is f of x. It is in red. Okay, so this is the function f of x. And this is g of x. It is in blue. And what I've done is I've put in the equation that we got whenever we added them together. I had to name it something else. I called it a of x. Desmos wouldn't accept f plus g of x. All right. Now, whenever we went through there and we plug in a value, so let's say that we looked at the value of 3. We got a value of 10. Okay. Sorry. For my f of x. And whenever I looked at 3 on g of x, I got a value of 11. There we go. Now, if I zoom out here and I look at the value of 3 on my f plus g of x, I get a value of 21. I don't think I'm going to be able to get it right. I did. There we go. I got a value of 21. Our graphical representations of what we're doing match up with what we're doing here algebraically. Okay? This is the algebra of functions performing mathematical operations on your functions. Make sure you structure your work. You think about what you're doing. Critically think about it. Okay? Watch your example problems from the publisher. Good luck with your homework.